Section 4.2, example 3. We need to solve an initial value problem. This is a second order ordinary differential equation, and it is homogeneous. It is of the form a y second plus b y prime plus c equals 0, and because of this 0, the equation is homogeneous. The first we should do is to find the solution, the general solution, and we can use the auxiliary equation which is the form ar squared plus br plus c equal to 0. And then we know that this is a quadratic equation that can be solved using the quadratic formula, which is r equals to negative b plus or minus square root of b squared minus 4 ac divided by 2a. Now in this particular example, the equation is a or 4 r squared minus 20r plus 25 equal to 0. So this equation you can solve it using the quadratic formula, but not necessarily, because this one in particular can be factored. So let's factor. So the factorization of this equation is 2r minus 5 times 2r minus 5 equal to 0. So if you can see, the two factors are the same. 2r minus 5 squared. And then this factor produces only one solution, which is 5 over 2. We have only one real solution. When you obtain only one real solution, so the solution is going to have this form: y equals to c1 e2 r1, or only r, because the r's are the same, r x plus c2 times x e2 rx. In this case, r is 5 half. So the general solution is going to have this shape: y equals to c1 e to 5 over 2 x plus c2 x e to 5 over 2x. Now, this problem is an initial value problem, which means that we have to find one number is c1 and one number is c2. We have to solve for c1 and c2. So the first condition given is y at 0 is 2. So we have y at 0 is 2. Then that means that 2 equals to c1 e2 5 over 2 times 0 plus c2 times 0 e2 5 over 2 times 0. Then here we conclude that this term is going to be 0, so c1 is equal to 2. Now, to find c2, we're going to use the condition given in the problem, which is that, let's look at it, y prime at 0, y prime at 0 is negative 6. Okay, so we need to find y prime. Y prime of x, right? Because these are functions of x, is going to be we need to find the derivative. So we're going to have 5 over 2 C1 e to 5 over 2x plus, then we have to apply the product rule in the second term because the second term is C2x times the exponential. So we have to apply the product rule, derivative of the first times the second, plus derivative of the second times the first. If we do that, we're going to have C2 e to 5 half x plus 5 over 2 C2 x e to 5 over 2x. So replacing the condition that y prime at 0 is -6, then we have in the derivative, we're going to have -6 equals to 5 over 2 times C1. Remember, the exponential to 0 power is going to be 1 plus C2 times 1 because e to 5 half times 0 is 1 plus 0 because this term, when you replace x by 0, will go to 0. Okay, so we have this equation, and we found that C1 is 2, so we're going to have uh, -6 equals to 5 because C1 is 2. When we replace it by 2, 2 and 2 are going to cancel. We're going to have just simply 5. So C2 is equals to -11. So the final answer, which is the solution of the initial value problem, is going to be y of x equals to 2 times e to 5 half of x minus 11x e to 5 half of x. And this concludes the problem.